Hi everybody. So in today's slideshow, I just want to go over dimensional analysis with you. So we've already learned a little bit about measurements and some of the units that we'll be using. So now we want to go over some of the math that we're going to do along with it. Dimensional analysis is a way to easily convert units of measurement. All right, and really the power in it is that once you learn the basics of how to do it, it will really make especially more complex problems much easier. Okay, so some simple conversions you probably know without really even thinking too hard about it. So if I were just to ask you how many inches are in 3 feet, you probably automatically think 12 inches to a foot. I have 3 feet. I must have 36 inches. All right, and so that's easy enough, but a lot of times we're going to encounter problems that are multi-step, and so we really need a way to keep track of our units and to make these conversions easier. So that's when dimensional analysis comes into play. So when we're doing dimensional analysis, what we want to do is first of all start with what we know in any question. So even if you're like, you read a question, you have no idea where to start, think about what information it's giving you. Okay, so in this case, we're starting with 3 feet. All right, so that's our known. And always, always, always write the number and the unit together. Okay, those two always belong together. So we have 3 feet. Now we need a conversion factor. So our conversion factor is just, in this case, how do we convert feet to inches, right? So that's our 12 inches in every foot. All right, and an easy way to think of this is we want to write what we want to know on top. So we want to convert to inches from feet. All right, so we know there's 12 inches in every foot. Now notice what's happening here with the math. So when I draw these parentheses, that means I'm multiplying. And when we're doing it, we can multiply across and we divide by what's on the bottom. So in this case, our units, notice these units, the feet are diagonal from each other. So when units are diagonal, that means we can cross them out. So we've now crossed out the feet and we're left with inches. And then we multiply 3 times 12 to get 36 inches. All right, so I know that seems more complicated when you probably knew it off the top of your head, but as we're going to see, this method really comes in handy as we get more complicated. All right. So as I said, always write your units when we're doing these problems, and it will get marked wrong if you don't. So always write units, and then always cross out diagonally. All right, so you cross out diagonally, so top and bottom can cross out. And you want to make sure all the units cross out except for the last one standing should be the one that is in your solution. Okay? All right. So a conversion factor we've already mentioned is just converting one thing to another, and it's really like they're actually equal. 12 inches equals 1 foot. So it's a ratio of equivalent measurements. Okay, I always think about it, if you live in an old house, you probably have electrical outlets that only have 2 prongs, right? So you need an adapter that will convert the 3 prongs to the 2 prongs. That's what we're doing. We're converting one unit to another unit, but the actual conversion factor are equal. Oops, I wrote over my own answer. So here are some examples from things we've done. 1 foot equals 12 inches, 1 cup equals 8 ounces, 1 tablespoon equals 3 teaspoons. One thing to remember when we're writing our conversions is you can think of it 1 foot equals 12 inches. That winds up being a fraction. So 1 foot equals 12 inches. All right, I'll just do my little dot dot for inches. All right, and so that is the same thing as writing 12 inches equals 1 foot. So you can flip these any way you need depending on how you need to cross out the units. So if foot's on top, then you use the conversion with foot on the bottom. If inches on top, then you got to use the conversion with inches on the bottom. Okay? All right, so let's go through some examples and see if this becomes a little clearer. So we're going to do some one-step problems first. And these are nice because you can double check yourself, as I said, because you probably already sort of know how to figure out the answers. So how many miles will a person run during a 5-kilometer race? All right, so we start out, and you start out with what you know. So what are you given? So we're given that we're starting with 5 kilometers, all right? And then we're going to write our conversion factor. So I use parentheses, and then it's going to be a fraction, okay? And we want to know miles, all right? So we're going to put miles up top because that's the unit we want to end up with. That means kilometers goes on the bottom, and that makes sense because these are diagonal, and we want the kilometers to cross out. So now let's look at our conversion factor, and we know that 0.621 miles equals 1.00 kilometers. All right, and so now let's go through. Kilometers are diagonal to each other. So this 5 kilometers is really like saying 5 over 1. So envision it like a fraction. So the kilometers cross out, and we're left with miles. And if we multiply through, you should get about 3.1 miles. So if you've ever run a 5K, you're running a little over 3 miles. Does that make sense? All right, let's try another one. A recipe calls for 0.5 liters of water, but you only have a measuring cup with ounces. Oops, shouldn't be, that's another question. How many ounces is 0.5 liters? So again, start with what we know. So we're given 0.5, sorry, my writing is so awful on these slides, 0.5 liters. All right, and now we need our conversion factor. So we're going to write our parentheses with our fraction. All right. Liters, we know has to be on the bottom because we want that to cross out. We want to figure out how many ounces there are. So what you're looking for is always going on top. And now my conversion factor that I'm given is 1 ounce equals 0.03 liters. So do you see how I'm just converting the conversion factor to a fraction? So the 0.03 always has to be with the liter unit, and the 1 has to be with the ounce. So no matter how you do this, you keep your number and unit together, okay? And so we then have the liters cross out because they're diagonal to each other. We're left with ounces. And now we're going to take 0.5 and divide it by 0.03, and we get 16.67 ounces. And that kind of makes sense if you think about it. So a liter is about a quart. And so you basically have 2 cups and half a liter, half a quart. So that kind of makes sense. All right. So a little bit of a math review that we've already been doing, but we need to be really careful of as we get to more complex problems. When you're doing these multiplications, so we're multiplying fractions here. So you got to go back to, I don't know if this is algebra rules or grade school rules when you dealt with fractions. So you're multiplying, basically these parentheses mean we're multiplying all these conversion factors. And that means we multiply across, so you could multiply across the top or multiply across the bottom. But if there's something, if you want to do math between the top and bottom, you divide the top number by something that's on the bottom number. Does that kind of make sense? And since it's multiplication and division, the order doesn't matter. So whatever's easier, I like to just kind of, in my calculator go along like this times this divided by that, whatever. Some people like to multiply both top and bottom, come up with an answer, and then divide through. Should get the same thing no matter what, okay? And then just a reminder, crossing out units is top to bottom. So remember, you may have done this in grade school where you had like 100 over 10, and you learned to cross out like the zeros. So you could do the math in your head. So 100 divided by 10 is 10. It's the same principle here. So again, we can cross out when they're diagonal, which means one's on the top and one's on the bottom. Okay. So let's do some with multiple conversions now to see how this works. All right, so let's do how many seconds are in a day. All right, so if you think about seconds in a day, you probably don't know a conversion right away. So let's think of the conversions we do know. We know that a day has 24 hours. We know an hour is 60 minutes. And we know a minute is 60 seconds. So now what we have to do is use these conversion factors, and we're going to start with day and end up with seconds. Okay? So here's how we do it. And notice they just, in their version, they didn't put the little parentheses. I'm a creature of habit. I was taught this way, so I tend to do it. But anyway, you want to start with one day. So start with what we know. And now we just have to keep going. So one day, day has to go on bottom. So one day is 24 hours. Now hours goes on the bottom. We know 1 hour is 60 minutes, right? Now minute goes on the bottom, and we know 1 minute is 60 seconds. So as we've been crossing out diagonally, so day, day, hour, hour, minute, minute, the only unit we're not crossing out is seconds. So we've now converted our days to seconds, and in this case, we're just multiplying 24 times 60 times 60, and we're getting our seconds, and that makes sense that it would be a big number, okay? All right, let's try some other examples. So we'll stick with our hours example. So this time we have 60 miles per hour, and we want to know how many feet per second. All right, so the first thing we're going to do is write out what we know. So we're given 60 miles per hour, and the first step, we can just do what we've done in those first few slides. So we need to convert miles to feet. All right, and so we know that 1 mile is 5,280 feet. That conversion had been given to us. So now the miles cross out. But look, we're left with feet per hour now, and we want feet per second, okay? So now we have to convert this hour to seconds, all right? So this is kind of, hour now has got to be on top so that it crosses out. So the two conversion factors we need now are still hour is 60 minutes, right? But now we have to put the 1 hour on top. So now our hour crosses out, and we've got minutes. So now we're at feet per minute. And then we would write in, we want to cross out the minutes. So 1 minute equals 60 seconds. So now we have feet, because that's what's left up top. And we've got seconds left on the bottom. So when we multiply this through, we have now converted to feet per second. So that's a little tricky because you got to convert both the top and the bottom. But the good thing is if you understand how this is set up, then you've got the idea of dimensional analysis. All right, and if we multiply and divide through, we get 88 feet per second. All right, so one thing you might want to do as we're going through these problems is double check with your calculator to make sure you're getting the same numbers. Just to sort of make sure you get the multiplying and dividing correctly, and also that you know how to use your calculator, especially as we get to exponents and things like that. All right, so here are a couple practice problems. So number one, how many minutes are in a year? So we're starting with year, if I can write it correctly. All right, and then we eventually want to get down, so we're going to drill down to minutes. So we know years on top, so we have to put year on the bottom. All right, so 1 year, and I only know that 1 year has 365 days. Oops, if I can write that out. All right, so now the years cross out and I'm left with days. All right, so now I need another conversion factor because we're not at minutes yet. So now I can know that 1 day, and I still don't really know how many minutes are in a day, but I know 1 day has 24 hours, right? So now days cross out and I'm left with hours. And now I need my hours to cross out, so I'm going to put hours on the bottom. And now I know that 1 hour has 60 minutes. All right, and then they're diagonal. So my hours cross out, and oops, now I'm at minutes. So as I said, if you set these problems up and you carefully write and cross out your units, the unit you're left with, if it's the correct one, you can't really go wrong. So now I'm just going to multiply, and here I'm multiplying straight through. And if you do this on your own, you should get 525,600 minutes. All right, so 525,600 minutes are in a year. All right, now the second one, how many days are equal to 1 million seconds? So 1 million is a 1 with 1, 2, 3, 4, 5, 6. So we've got 1 million seconds. All right, and hopefully you know that that's 10 to the 6 seconds, but I thought I'd write it out. So now we're going to go seconds, and I got to get to days. So I'm going to do the same thing. Start with what needs to be diagonal. So seconds needs to cross out. So we write that down here. All right, and now I know seconds to minutes. So I know that 1 minute is 60 seconds. Okay, and then, so now we know seconds cross out and I'm left with minutes. So now minutes will go on the bottom because we need to cross that out. And now I know that minutes, let's see, I need to get to days, but I know that there are 60 minutes in an hour. All right, so now minutes crosses out and I'm at hours. And then finally, I can add my hours in here. And I can do hours to days. And I know 1 day is 24 hours. And I cross out my units. And if you do this, you should get 11.6 days. All right, and always double check and make sure this makes sense. So 1 million seconds, it's going to be a much smaller, you have to end up with a smaller number because you're going from seconds to hours. All right, so that's dimensional analysis. Now we're going to combine it with what you've learned from the metric system. So remember, you saw a chart like this. These are our unit conversions in the metric system. So these are our prefixes, okay? And this table is showing you that each of these prefixes, so if I have let's say I have 1 kilometer, I know 1 kilometer equals 10 to the 3 meters, all right? So it's always one of the prefix equals this many base units, okay? So 1 centimeter equals 10 to the minus 2, which is 0.01, sorry, 0.01. All right, 1 millimeter equals 10 to the minus 3 meters. If we were doing liters, so your base unit can be anything. So it could be 1 microliter equals 10 to the minus 6 liters. Do you see how those conversions work? All right, so first thing, these are the prefixes you're going to memorize. So you should know basically 10 to the minus 9 up to 10 to the 9th, okay? And so let's go through some examples as we do this. So how do you use dimensional analysis with metric system? So how many millimeters are in 0.35 meters? So remember, we're starting with what we know, so 0.35 meters, and we want to convert to millimeters. So meters goes on the bottom, so we can cross out. And now we need to know our conversion. So we're going to look at our chart, and we're going to go down to milli, and we know that 1 millimeter is 10 to the minus 3 meters. Okay, so now we can write this out, and we have 1 millimeter is 10 to the minus 3 meters. And here's where you want to double check your calculator and make sure you know how to use exponents on your calculator. You should get 350 millimeters. All right, here's another one. So let's use watts as our base unit. So we've got 3 times 10 to the minus 3 megawatts. So let's look on our chart for mega. So mega is up here. So 1 megawatt is going to be 10 to the 6 watts. All right, so we write 3 times 10 to the minus 3 is what we're starting with, megawatts. Here's our conversion. So remember, it's 1 megawatt, so our megawatts cross out, and we're ending up with 3,000 watts. All right, a little trick you might remember from math is when you're multiplying exponents, you're adding them. So if you take 10 to the minus 3 and you're multiplying it by 10 to the 6, right, you're ending up with 3. So minus 3 plus 6 gives you 3. So 10 to the third is 1,000 times 3. That makes sense? Anyway, it's a little double check if you know it. So when you multiply exponents, you add the 2 exponents. When you divide exponents, you subtract them. So it's a good little double check of your calculator. All right, and just like we did before, we can use 2-step problems. So here we're going from kilometers to gigameters. So we're not going to the base unit. So there's no direct conversion using our chart anyway. So what we want to do is we're going to start with gigameters. All right, and so the first step is always to convert the prefix to the base unit. So we're going to go gigameters is 10 to the 9th. So 1 gigameter is 10 to the 9th meters. The gigameters cross out, and we're left with meters. Now our next step is we got to figure out how to get kilometers. So now we convert meters to kilometers, and we know that 1 kilometer is 10 to the 3 meters. All right, and can I move I can't move myself out of the way, I think. I can turn myself off for a second. So here, notice I've crossed out, and then here's that little trick. So 10 to the minus 2 times 10 to the 9th is 10 to the 7th, divided by 10 to the 3 gives you 10 to the 4th, and then the 5 is just carrying through. So you can do it on your calculator, or you can do it in your head. All right. So here are some practice ones for you to try. I'm not going to go through them all, but you can see if you get the right numbers. Here will be the answers, okay? So you can always kind of work backwards if you don't get it the first time and see how those units set up. All right, so just a little note is that dimensional analysis, everybody learns it. It's like the same thing, but they learn slightly different ways to set it up. So the parentheses is the way I use, and I think your CK12 book does. You may also see it written out like this. So they're just using the lines to sort of set it up where you're multiplying across the top and then dividing by the bottom. Sometimes people will write it out like that one example where they're actually put like the multiplication sign in between. All right, so it's just different ways of doing the same thing. On another note with these conversions, so that chart, remember, if you look at the chart directly, it's going to say 1 millimeter is 10 to the minus 3 meters, because milli means 1,000th. So this makes sense. But keep in mind, you can reverse it. So 1 meter has 10 to the 3 millimeters. So 1 meter has 1,000 millimeters in it. So that makes sense. So 1 millimeter is 1,000th of a meter. So if it's 1,000th of a meter, then 1,000 of them make 1 meter. Does that make sense? So you can, 1 micrometer is 10 to the minus 6 meters, or it can be written as 1 meter is 10 to the 6 micrometers. So what you have to keep in mind is going from small to large, what's happening here, right? So micrometer is really small, 10 to the minus 6. Kilometer is 10 to the third. All right, so, and I just put the number of arrows in here. So there's 1,000 micrometers in every millimeter. There's 1,000 millimeters in every meter. And then there's 1,000 meters in every kilometer. All right, so however you want to use those, I try to use the table because that's what you guys are like memorizing, but sometimes I inadvertently slip and do it the other way. But they both mean the same thing. So hopefully you can kind of see that. All right, hopefully that helped. It was a little longer than I thought it would be, but it's nice to kind of go through step by step. So now that you've gone through it with me, try some of the problems on your own that are on the worksheet. Don't worry if you get stuck. Do what you can, and we'll work through some of the ones everybody has problems on later. Okay? All right. Have a good day.